out of necessity, I've had to purchase one of these optical audio switch. This is basically a TOSLINK, optical TOSLINK switch, which is remote controlled, or it can be controlled manually by pressing this button as well to select the input. It's powered, so it's an active switch. Now this, although it's branded Lindy, if you look online you'll find that these switches are quite generic and they are sold under quite a variety of brands. In fact, this one's just rebadged as Lindy, so there's nothing special about this brand whatsoever. However, it comes in a nice box, Lindy box. So I think if you're looking for something similar, I would recommend going with Lindy anyway, because they seem to have a huge range of similar products which have all been rebranded under their brand, and they've got a very good warranty policy, etc, etc. So at least this one has, although I don't believe it's made by them, at least they will stand by it when if you do face any problems or require any assistance over the lifetime of this product. Now this is powered by a 5-volt DC adapter. So as you can see, it comes with 4 different types of power socket heads. So there's an Australian one in there, there's that one there is American, and of course the UK plug and the Euro 2-pin plug. Now that's the remote control. Just keep in mind the IR port is on the side, so it may not pick up signals from the remote control when pointed from the front. Okay, so why did I have to go down this route? Simply because I used to use a physical switch like this. So this is a TOSLINK optical switch that is passive, and not just passive, it's just a physical switch with no electronics or whatsoever. Now the way this works is, if you open it up, what you'll find is there is a short strand of fiber optic cable that runs along the middle of this unit. So one end of the fiber optic cable is sprung onto the input port. In fact, it's visible there. You can see the white center core of the cable, and basically what this does is it slides the other end of, when this button is depressed, it slides the other end of the fiber optic cable out from the port at which it's pointed to at the moment. So at the moment it has port number 1 selected, so by depressing this button it retracts the cable from port number 1, and then you move it to port number 2, it springs back into port number 2 and shoves the cable into port number 2. So as you can see, the cable is now in port number 2. You can see the white center core once again, and you can't see it on either of the other 2 ports. Now, the problem with this switch is it doesn't really work, and a lot of people will testify to that as well. You can read a lot of reviews online and a lot of testimonies from people, and this stuff just don't work, because one of the main reasons why it fails is because when the input cable, sorry, this is actually, I'm using this as the output and I'm using those as the input, but basically when you connect a TOSLINK cable into this unit, you have to ensure that both the connecting cable and the internal fiber optic cable are pointed towards each other at a straight angle, and the possibility of that happening is very, very slim. So if you just imagine this being a fiber optic cable, a TOSLINK cable, if you connect it to the port like so, there's bound to be a bit of free play, so the cable will either rest towards one of the other angles, thereby reducing the possibility of having a straight angle input against the internal fiber optic cable. And even if you do get the input to line up perfectly with the internal cable, you also have to make sure that the output port, the cable in the output port, is aligned perfectly with the output cable as well. Therefore this design increases the possibility of a malfunction that will result in a number of situations. The most common situation being no audio coming out from your audio system at all, or you may be able to play a track and you will notice skipping along the way, because not all of the beats are being transmitted through to the receiving end. There are also some situations where you've connected this properly and you find that you are able to play lower bitrate sound streams, such as from a CD transport, for example, that runs at 44 kilohertz at 16 beats, or you may even be able to play uncompressed FLAC at 48 kilohertz 24 bits. But as soon as you try to play a higher bitrate sound file such as a 9624 flag, then the entire track will be inaudible on the receiving end, and that's because the misalignment of the fiber course greatly reduces the bandwidth of the transmission between the input and the output of this device. And I'm speaking from my experience with 2-channel uncompressed streams. So imagine how likely these units will fail if and when they are used for higher bitrate streams such as Dolby Digital 5.1 or DTS streams. Therefore, an electronic active switch like this is certainly a worthy investment in the long run. Thanks for watching.